Okay, the Chapter 4 exam review will be in two different videos. This is quite long, but here we go. Find the line of symmetry. Line of symmetry is x equals negative b over 2a. You've seen that a bunch. So the negative of b is actually positive 10, and then 2a, a is 1, so 10 over 2 is 5. So that line of symmetry is x equals 5. The y-intercept, it's the same function. Think about it. When you plug in 0 for x, you get the y-intercept. So when you plug in 0 here and here, these two cancel out and you're left with just the 7. So you can look at C, and that is your y-intercept. And for the vertex, you need to take the line of symmetry. Okay, so if we were going to, sketch the graph of this real quick, 1, 2, 3, 4, 5, we know this thing is symmetrical at x equals 5. Now, I need to go plug x back in to find my y value of my vertex. And when I do that, I plug that in, I get 25 minus 50 plus 7 is negative 18. So it looks like this vertex is way down there. Okay, so it's off most of our graphs, but that is our vertex. Okay, so number 4, describe the translation when you have y equals x squared minus 3. What they're saying here is compared to y equals x squared, I'll just rewrite it, what's the difference between these two? So we used our graphing calculator to explore this, and we put x squared in one of them, and we put x squared minus 3, and we graphed the two, and you see the only difference is that it moved down 3. So remember, it's all it's asking for is what's the movement of the graph. Okay, so describe the translation. Now when it was in parentheses, compared to y equals x squared, if you put those both in your graphing calculator, this one is going to move right 3. Remember, if it's negative, it goes to the right. If it's positive, it goes to the left. It's actually the opposite of what you think would happen. Okay, so this one moves right 3. Okay, number 6, you have parentheses and a number. Okay, so this single number is going to make it move up and down, and this is going to make it move left or right. All right, so this one goes left 2 and up 5. Okay, so, and then also, if you think about this, this is vertex form, and we can think about the vertex by just looking at this part and this part, and the vertex is negative 2, 5. All right, so if you think about that, the center of this graph moves left 2 and up 5. Compared to y equals x squared. All right, number 7 is just graph a quadratic function, and we get that by finding the line of symmetry. Negative, we just did that, negative b over 2a is how you find the line of symmetry. So negative of negative 8, or the opposite of negative 8, is 8 over 2a. 2 times 1 is 2, so the line of symmetry is x equals 4. Okay, the vertex, when you plug in 4 for x, you should get negative 1. Okay, so this is 1, 2, 3, 4. So we know it crosses, or that's the vertex right there. It's symmetrical on that point. Okay, now it says chart here. You're going to be allowed to use your graphic calculator on at least this portion. But, we did this by hand quite a bit. So if we plug, other points around the vertex and see what we get. We'll get a couple more points, and then we'll go from there. So when I did that, you plug in 5. A lot of us used our graphing calculator. We got pretty good at this. Clear these out. X squared minus 8x plus 15. You can press graph and kind of get an idea of what it is, but second table gives us a lot more information. When we plug in 5, we get 0, 6, 3. So 5, 0, 6, 1, 2, 3, even 7 looks like it fits. All right, so 7, 8 also fits. And then, since we know it's symmetrical, something that looks like that. Now, domain and range. Domain, all x's. It doesn't matter what I plug in for x, I'll always get a single y. All right, so all reals or all real numbers will work. And then the range, it goes from here up. Okay, remember range is a y thing. So the smallest y is -1, and then that heads to infinity. So our range went from -1 to, forever on up. And then solutions. Solutions are x, really, it's asking for x-intercepts. So our two solutions, it looks like, is 3, 0 and 5, 0. Okay, solutions are where this graph is equal to 0. Okay, this is quadratic inequality. We just actually got done doing this. Our line of symmetry here is -b over 2a. So negative, opposite of b is 2. Over 2 is 1. So our line of symmetry is x equals 1. I plug that in. You really get 1 squared. 1 minus 2 times 1 is 2. So 1 minus 2 is -1. Minus 8 is -9. So 1, -9. Then crosses all the way down here. Now I know it doesn't ask for this, but our y-intercept, plug in 0 for these two, and you get -8. So I know it crosses there. And then since I started that way, maybe I'll try -1 and -2. Plug those in. So plug in -1. That's 1 plus 2, which is 3, minus 8 is -5. Plug in -2, that's 4, plus 4, that's 8. 8 minus 8 is 0. So, plug in -1, 1, 2, 3, 4. So we knew that was symmetrical. This is only greater than, so we should have some dashed lines. So it's a decent graph of that. Now we need to shade. Do we want to shade inside of it or outside of it? Well, to do this by hand, we test 0, 0 and see what happens. So when I plug in 0, 0, I get 0 is greater than -8. Okay, because this is these are all 0. Think about it. So is 0 greater than -8? That's true. It's a solution. So 0 is greater than -8. So we're going to shade inside of there. All right, number 9. Factor. Now you notice that it doesn't say solve by factoring. All it wants you to do is factor. That's it. Two things that multiply to C. So factors of C that add. Factors of C that add to B. Okay, so when I think about those, and you guys are pretty good at listing the factors, if I do -5 plus 2, those two multiply to -10, but they add to -3, and we're done. You do not need to get x equals a number. Okay, this one here, our second strategy of the year was to just kind of guess and check and kind of go from there. So now you can do the whole A times C and do that whole strategy, but this one seems so simple. There's only one way to get 2x squared, and that's 2x times x. There's no other way to do that. So there's only a couple ways to get -6 also. So if you think about this, I need more negative than positive. So if I put the -2 over here and the +3 here, when I FOIL this, I get 2x squared minus 4x plus 3x minus 6. And there you go. When I check this out, I get negative 1x in the middle. Okay, so this must be factored correctly. So what they're looking for is that right there. Just the factored form, that's it. No solving. Now number 11 asks you to solve by factoring. So yes, I need to factor this and then I need to solve it. Two things that multiply to positive 12 but add to negative 7 are negative 4 and negative 3. So if I set both of these equal to 0, now I have x equals 4 and x equals 3. Those are my two answers that work. And you can always plug this back in and see if you're right. Okay, so plug that in. You get 16. 4 squared is 16 minus 28 plus 12. So 16 plus 12 is 28, and then you have a negative 28 in the middle that makes 0. So you can always plug this back in to both x's to see if you get 0, to see if you're right. We probably didn't do that enough this year. Alright, solving by square root. Remember, this is just solving by algebra. You know, solve. I know you guys probably are sick of this, but PEMDAS backwards. Get rid of the addition and subtraction, get rid of the multiplication, and then mess with the exponent. So I subtract the 1, I get 12. Get rid of the 2 before you square root. Now the exponent is all by itself. Now I'm going to square root both sides. So x equals, number one mistake is forgetting to write the plus and the minus radical 6. Plus and the negative root of 6. Or negative 6. The positive and negative root of 6. Okay, number 13. This one's a little different. We have a quantity squared and we have a negative 5. So before I do anything with this square root, I still want to get rid of the subtraction first. Now, I have a quantity squared, so it's really like I have the exponent by itself. So now I can square root that, and this quantity squared, take the square root of anything squared is you just get that what's underneath. Alright, now I can simplify this. Radical 20 is 4 times 5. Alright, so that becomes 2 rad 5. And then, and actually I should write it as plus or minus. And then I'm going to add 3 to both sides. And I have x equals 3 plus or minus 2 rad 5. That's my final answer. Okay, 4 more. So long videos. Alright, here we go. So quadratic formula. Hardest part is remembering the thing. Negative b plus or minus the radical b squared minus 4ac over 2a. So b is 6, so I'm going to get negative 6 plus or minus b squared. I just like to square the b right off the bat instead of writing 6 squared here. That's 36 minus 4ac over 2a. Alright, so I just went ahead and squared the b and wrote it like that. Negative 6 plus or minus. When you put this all together, this is where the number one mistake lies. This is 36 minus 40, which is negative 4 over 2. So since I have a negative radical, and that's actually a perfect square, that's 2, and that's a negative 1, bring the negative out, it becomes I. So I have negative 6 plus or minus 2i over 2. Now everything is divisible by 2, so you get negative 3 plus 1i over 1. But if you think about that, the most concise way to write that is without the 1 on the bottom. So negative 3 plus, forgot the plus or minus 1i is our final answer. Now, we didn't do a whole lot of this, but it says what type and how many solutions did it have? Well, really this looks like one solution, but really it's -3 plus 1i and -3 minus 1i. So the answer to that, it has two solutions. And what kind of number is this? This is called an imaginary. So two imaginary solutions. All right, number 16 is another quadratic formula. Negative b would be positive 8 plus or minus b squared is positive 64. Anything squared, so negative 6 squared is 64 minus 4ac over 2a. So you get, when you put this all together, you get 64 minus 40, which is 24 over 2. So 8 plus or minus, now this can be broken down into 4 times 6, and 4 is a perfect square, so that's 2 rad 6 over 2. Again, everything outside of here is divisible by 2, so I get 4 plus or minus rad 6 over 1, which anything over 1 is just itself. So there we go. You notice that I did not cut the 6 in half. I don't want to do that. The 6 is kind of protected. It's underneath the rad, so radical sign, that's not going to be divisible or divided by 2. So again, we have two solutions, all right, because that's 4 plus rad 6 and 4 minus rad 6. All right, so we have 2, and then these are, if we want to be technical, we have, these are not imaginary solutions, but they're irrational solutions, because rad 6 is an irrational number. Okay, if this came out as, let's say, -5, x equals -5, and x equals 7, okay, those two that would be two rational solutions. Okay, so irrational. An irrational number is a number that is a decimal that never repeats. So, and it never stops. So if I do rad 6, you'll notice that it's a decimal that doesn't repeat and it never stops. All right, so whenever we have a non-perfect square, all right, tacked onto our answer, it's going to be an irrational solution.